Okay, hello. Welcome to another video. I'm going to try to do this in video form so that we don't have to talk as much in class and, kind of lecture about this in class. We're going to start I'm going to have this broken up into two parts. It's going to be the same presentation, but I'm going to continue it in another video. First off, I would like to talk about our units on evolution, and I want to talk a little bit about the history of how the current theory of evolution has been kind of came to be. I want to start off though. Let me get this screen thing off here. I want to start before I really get into the PowerPoint. Just remind you that we're going to be talking at the beginning here about modern evolution today, but I want you to remember that when this was all being discovered in 1500s to 1600s to 1700s, as these theories got talked about, there was a huge argument between people who were with the church, who believed that God created man in his own image. And then the group that we're going to talk about were called evolutionary biologists, who believed that man kind of changed over time, and that's what evolution means. And there are ways to kind of put them together, but I'm going to right now kind of talk about a few of these evolutionary biologists, and I'm going to talk to you a little bit about how they came to think of this theory of evolution as being different than the Bible might have claimed. And the first guy was a French naturalist. His name was Georges Buffon. And Buffon was a guy who studied fossils. Fossils are one of the ways that we currently use to try to explain how we can prove that organisms are really kind of changing over time and coming from other organisms, as opposed to being put here special by God. And that's kind of where I'm going to keep framing stuff, because that was the argument at the time that this was all being discovered. So this guy Buffon, he came around and said, all right, I see some fossils, look like this one over here on the right. I don't know if that's an iguana, or it looks like some kind of an iguana or reptile of some kind in the desert. And he said, I see this creature, and I see these fossils, and I'm noticing a few things. And the first thing I'm noticing is that they seem to have kind of similar structures to us. Look at these arms here, and what you'd call fingers, the spine and the ribs, etc. like that. A lot of them are the same. Even the skull has some similarities up here. The second thing that he noticed is that he decided that, based on what he was seeing, that and doing some testing and some suggesting and some theorizing, he basically came up with an idea that he didn't think the Earth was quite as young as the religious people that were saying. Most religious people at that time were claiming that the Earth started at year zero. At Adam and Eve, God created man in his own image, and this guy Buffon came around and said, no, the Earth is way older than that. So, and it turns out the Earth is it's thought to be about 4.5 billion years old, not, let's say, 1,700 years old, like in 1700. So we now know that we don't start time at zero, but back in these days, this is what the Catholic Church believed. And so Buffon was kind of controversial for that reason. He was trying to argue that the Earth is way older than when God created it, or when we thought God created it, or something like that. So that was his contribution. That will come back a little bit when you talk about how old things are, and when we start talking about fossils a little bit. Then there's another French naturalist. His name was Jean-Baptiste de Lamarck, or just Lamarck. And he kind of was the first guy to say, I don't believe that God created man in his own image. I believe that life started with something, and that it changes over time, and that we as humans are the result of that change. And we know that to, at least scientifically, be something we can try to show and have evidence for, and that's what we're going to do in our next video. And I'll talk about that evidence. But so that part's right. But the second bullet point here is something that you probably might sound true at the beginning, but I'm going to explain it to you a little bit here. And that is a theory that he called acquired characteristics. Basically, he said if organisms use the certain parts of their body and use them well, they will pass them on. If they don't use certain parts of their body, they will end up losing that part of the body, and they won't have that trait. Now, I put this picture of a guy with the muscles here because muscles are an example of something that might sound like that's true. If you build your muscles and use them more, you're going to build them up more and have bigger muscles. And certainly if you don't use your muscles, they get weaker. But what Lamarck would also suggest was that something like a giraffe, who needs to get leaves out of a tree, that if it just kept stretching its neck and using its neck, then its neck would evolve and change, and so over time the neck would get longer. Now we know that that's not true. We know now that our knowledge of DNA, we kind of know that something like stretching your neck doesn't make you taller. What makes you taller are what your genes say. But Lamarck was still didn't know really much about genes at the time. This is way before Watson and Crick and discovery of DNA. And so his theory of acquired characteristics said that anything that you use, you'll keep, and anything you don't use, you don't keep. And that's a really controversial kind of statement to say, and it's really not true when you think about it. I want you to picture for just 1 second before I move slides. I want you to picture somebody who has a problem and has to have a finger gets cut off or something terrible like that. Their kids aren't going to be born with no fingers. But according to Lamarck, if you lose your finger and you're not using it anymore, then the next organism that evolves from you isn't going to have that part. It's not going to use it, not going to have it. So we know that that's not totally true. But we do know that we believe we have scientific evidence to prove Charles Darwin. Charles Darwin came mid to later 1600s, I think, and he was on a ship that he called the Beagle. It's kind of a well-known name for his boat, and he worked on a certain group of islands called the Galapagos Islands. They are mid-equator, kind of east of Venezuela, and they're supposedly beautiful. I've never been there, but there's a lot of scientific experiments done there because they are little tiny separated islands. And he did a lot of boat traveling between the islands on this Beagle and noticed that a lot of the animals and plants looked really similar, but for example, this reptile you see here had longer and bigger claws and hands in one island and smaller claws and smaller hands in another island. And so he noticed that there were differences depending on what island they were on. He also noticed that there was that correlated to the kind of food that was there. For example, the organisms of the lizards there who had bigger claws, they actually were found to be in environments that had more trees. Maybe we would think it's because they had to have claws to climb the trees. So Darwin kind of came up with two main points. His first was called descent with modification. Modification means to change. This says basically that organisms, as they have babies, over long periods of time, over the species, will accumulate what we call adaptations, things that are helping them live in a particular environment. And so descent with modification says that we descended or came from a modern ancestor, a common ancestor. Kind of think of along the lines of how some people say we're like related to apes, that we came from a common ancestor and that we accumulated adaptations to the environments that we were then put in. And connected to that was his idea of natural selection, which basically says that, all right, organisms will acquire these adaptations, like I just said, but also that organisms who have these traits are going to be more favored by nature, and they're going to have more offspring because they have traits that enable them to survive in the environment. That's what we call adaptations. So one says we've descended from a common ancestor and have accumulated adaptations, and the next one says these adaptations help us, and therefore organisms with those favorable adaptations will produce more offspring. Natural selection means we select naturally by having environments where the person or organism has to have traits to enable it to survive at that, or it doesn't probably survive after a long time. In the next movie, I'm going to bring up to you some of the evidence that we have for evolution, and I don't know what that is, but I'm going to escape, and I'm going to see if this one worked, and we'll check for a second video. Thanks, guys. Come back for evidence of evolution.